So for this one, we're going to actually use the double angle formulas to establish an identity. So the reason why double angle formulas aren't useful for the last type of problems we had for finding exact values is, think about this idea here. So if I had this angle here, and let's say I knew it, let's say it was, let's say I had 60 degrees. Now if I take half of it, my theta is going to be 30 degrees. So I already know 30 degrees. So if I'm taking half of an angle, I'm going to know the angle itself because I'm doubling it. So therefore, it's not very efficient to use for finding exact values. So we are going to use this for this establishing an identity though. So cosine of 4 theta, I'm going to start with the left side here. Mostly I would say start with the more complicated looking side, but the left side I have double angle formulas, which makes it more complicated right away. That's why I'm actually using the left side, or the simpler looking side this time. Okay, so cosine of 2 theta is what I'm going to use here. But I'm going to use this last one here. And I'm going to use the last one because notice my answers, they have cosine squareds in them and stuff. So if I look at these two, I have sines in them, so I'm not going to use those two. So I'll actually just use the last one because that's going to give me those cosine squareds because that's all it has. So here we go. Okay, so I'm starting with the right side. This is really cosine of 2 times 2 theta. Now if you look at this formula here, my theta for this one here is going to be 2 theta. Okay, so I'm going to put in 2 theta here. Okay, so this is going to equal 2 cosine squared 2 theta minus 1. So there's our first step. And now we're a little closer to our final answer. Now keep in mind here, this little 2 here is really like taking this whole thing here and squaring it. So this is kind of what we're going to deal with next. So getting back to our problem at hand now, we have this 2 theta again, cosine of 2 theta again. So this is going to equal 2, and then in here I'm going to have that cos of 2 theta squared minus 1, which this equals 2, and what is cos of 2 theta again? It's going to be 2 cosine squared theta minus 1 minus 1. Don't forget my squared. Okay. So now this is going to be a FOIL in here. It's like I have 2 of those. Now I went along and actually FOILed that out here. FOILed this piece out right here. So now we're ready. Alright, so here it is. And all I'm going to do now is distribute the 2 through here. So here, oops. So here, here, and here. And then subtract the 1 from it. Okay, so let's go and do that now. So then this here is going to equal 8 cosine 4 theta minus 8 cosine squared theta plus 2 minus 1. And then our final answer then is going to be 8 cosine 4 theta minus 8 cosine squared theta plus 1. And if you look at what we're trying to show there, that's the identity. So again, we use the double angle formula to establish an identity. Sometimes we can use these in equations also, and we'll get to that later.